everyone. Welcome to the course of Microwave and Radar Engineering. In today's class, we are going to see the overview of the syllabus with respect to the radar engineering. So this may be a little bit varying from university to the university. So right now, I'm going to give you a scope of all the 5 units present in the Anurag University Microwave and Radar Engineering. So coming to the course objectives. So in order to develop the knowledge on waveguide components and their applications, and also radar fundamentals and radar signals, okay, that is one of the objective. And not only that, in order to understand and analyze the operation of microwave tubes like klystron, magnetron, traveling wave tube, and also few radars like CW radar, pulse radar, MDA radar, etc. And also to analyze the operation of microwave solid state devices and some tracking with respect to the radars, and also to understand the concept of microwave junctions, their scattering parameters, and to detect the radar signals in the presence of the noise. Okay. And last, in order to analyze microwave test bench or the workbench, and we are also going to measure different parameters like attenuation, power, voltage, standing wave ratio, etc. And we're also going to analyze the radar receivers. And let's see the course outcomes. So if you go through the course outcomes, so after the completing of the course, the student will be able to describe the significance of the waveguide components, and also the fundamentals of radars and the signals. And not only that, they can be able to analyze the characteristics and the working of the microwave tubes and also different radars. And they should be able to, or they can be able to explain and analyze the operations of microwave solid state devices and radar systems. Along with that, we can also apply and analyze the concept of microwave junctions, scattering parameters for different components, and radar signal detection. At last, we can able to, or the student can be able to analyze and evaluate the microwave measurements and radar receiver. Okay. To the textbook, Microwave and Radar Engineering by M. Kulkarni. So this is one of the best prescribed textbook for in order to cover both the microwave and radar engineering. Coming to the units. So the first unit covers the rectangular waveguide and waveguide components. Coming to the basics of what are microwaves, their characteristics, features, advantages, and applications. And not only that, we are also going to learn what actually the waveguides are, what are its concept, what is a TMM, TE modes. We are going to solve the equations of the TE and TM modes. And not only that, we are going to see how the power flows in the waveguide and how the power is lost in the waveguide. Okay. And coming to the waveguide components, this will be dealing with the construction and working of the microwave components like coupling mechanisms, coupling probes and coupling loops. We also have waveguide windows, tuning screws and tuning posts. We have attenuators, phase shifters, and several waveguide multiport junctions like E-plane T, H-plane T, and magic T. Okay. In Unit 2, we are going to cover the scattering matrix and microwave tubes, where the scattering matrix is the extension of the waveguide multiport junctions, where we will be dealing with the scattering matrix derivations of E-plane Ts, H-plane Ts, and magic Ts. And we are also going to see the concept of directional couplers. And coming to the microwave tubes. So what can be how the microwave tubes are different from the conventional tubes or the traditional tubes? What are its limitations? How the losses of the conventional tubes occurs at the microwave frequencies? And we are also going to see the construction and operation of two cavity klystron, reflex klystron, traveling wave tube, magnetron, and so on. Okay. And coming to the Unit 3. Unit 3 is completely related to the microwave solid state devices and measurements, such as construction of TEDs, ATDs like gun diodes, avalanche transit time devices, impact and trap diodes. Okay. And not only that, the most important aspects of the microwaves, like microwave bench setup and how the power is measured, like using a bolometer and measurement of attenuation, frequency, voltage standing wave ratio, everything will be learned in this unit 3. And coming to the unit 4 and 5, it completely covers the concepts of radar engineering. So coming to the radar engineering, unit 4 is completely on radar principle and its types. So we are going to see the wide varieties of radar types, and also we are going to see the radar range equation and its frequencies also and applications. So uh, we are going to see few radar types like CW radar, MTI radar, okay, Doppler radar, etc., where we are going to construct the block diagram, and also we are going to learn about each and every block of the particular diagram. And coming to the tracking radar and radar receivers, we are going to see the principle and operation of the radar receivers, and also we are going to see what are the monopoles and how the tracking is done with the help of radars. And coming to the radar receivers, we are going to see what is the noise figure and noise temperature, what are the duplexers, how they are acting as a switch, how the circulators are used as a duplexer, we are going to see. Okay. So this is the overview of all the 5 units. Mostly each and every college or any university will be comprising almost the same amount of topics. So this course will be very much beneficial for the understanding of microwaves and radar engineering for any kind of knowledge, and also in exam point of view.